Hello. Can you hear me and see the desktop?
Yeah,
Yes.
we can hear you.
Okay, great.
Yes.
Thank you. Okay. Okay, looks like everybody's here already. Okay. All right. So today we're going to talk more about homework assignment one, the first programming assignment. We're going to look at the examples in these two folders here. So first, does anybody have any questions? Anything come up in the last couple of days? Anybody have a question they want to ask right away? Anything? Okay. Now let's go ahead and on Monday, what we did was we looked at running the homework assignment. So we used the demo version of the homework assignment to run it to get a sense of what it's supposed to do. So today I want to start looking at the code that's behind it. Whoops. Here's a little trick. Sometimes I forget to update the links. If you click on a link and it's not there, here's a trick that you can sometimes try. Web servers are just computers like any other computer, and this is a file in a folder. If you shorten the URL to the folder level, you see what's in the folder. See, the web server shows you what's in that folder called CS302. Okay, I'm looking for the homework assignment, and I actually put it in this folder here. See, it's right there, and I forgot to change the URL. I moved it into a subfolder. So there's the zip file. So it's right there. This works on a lot of websites. If you click on a link and it's dead, you just shorten the URL from the file to the folder, and you can start looking at what's inside folders. So you can see what's inside that folder. You can go up a directory, but if you go up a directory, you don't notice how this URL works a little bit different. This one doesn't show you the folder. It shows you my website. And that's something that the person writing the website controls. I can control whether a folder shows you the folder or if a folder shows you a web page. So for this one, it shows you a web page, but like for this one, it shows you the contents of the folder. This one shows you, and that's actually real useful. So it's a good way to find stuff on people's websites. So, sometimes people have all kinds of interesting things up on their websites. They don't necessarily have links to them, but they're in their folders. Okay, so you can just and notice it's a lot like the way you should think about it, and that's why Microsoft originally designed this is this bar up here is like the bar here in the Explorer. You know, it acts a lot like the Explorer bar. This address bar here acts a lot like the address bar in the Explorer. Remember, Microsoft's web browser is called Internet Explorer, and this guy is called File Explorer because they thought of them as working very similarly. This one explores files and folders on your hard drive, whereas the other one explores files and folders on web servers. So there's a lot of analogy between the browser and the Explorer. Okay, so you can shorten URLs on the address bar. Sometimes it works, sometimes it doesn't. Okay, like again, if you shorten to this folder here, you get a message from the administrator of the server. You don't see what folders are on the server. You get a message from the administrator of the server. Okay, so all right, so I got to update that link on my website, and then here's the homework. Oh, and I got to update that one too. I forgot to update those. Now that one's just the homework assignment. So that one is actually a link to this zip file here. Okay. Right, so I've got the two zip files downloaded, and we want to look at want to look at the code a little bit. The code that this explained here. You know, this explains it. We talked on Monday mostly about running the homework assignment. Today we want to start looking at the code. Okay, so let me unzip these. Okay. What happened to this one? Oh, I forgot to click extract. Okay, I don't need the zip files anymore. Okay, the homework folder has the code that you have to, you have to write this file here. Now there's a bunch of subfolders here that have information. So some of these subfolders are just, some of these subfolders have example programs in them, excuse me, and some of them just have links to, oh, I'm sorry, excuse me. They have links to documentation and, well, this one's just links to websites about Windows command line. So this is, unfortunately, I cannot find one good reference about the Windows command line, okay? I can't find a really good reference that just says, here's a good way to learn about the Windows command line. There's tons of books written about the Linux command line. Great books have been written about the Linux command line. I can't find a single good one that's written about the Windows command line. So here's a bunch of references. They're pretty good, but they're small references. Instead of being one self-contained reference about everything you need to know about the Windows command line, it's just a page here, a page there that tell you good things, but you have to read a page. And it wasn't easy to find all of these. So there's some help files about the Windows command line. And we'll be using it and talking about it as we go along. And we did, most of what we did on Monday was seeing how to work with the command line rather than just double clicking on things. Okay, and then these are things that you have to do with the homework assignment. You have to use command line arguments, you have to use environment variables, you have to read files, okay? And you have to read from standard in. So these are going to be talk about today. What is a command line argument in C? The key here is in C. What's a command line argument in C? What's an environment variable in C? How does a C file read how does a C program read a file? How does a C program read from standard in and write to standard out? Okay, so, and actually there's two things about scanf. Scanf is how you read from a file. Okay, so we're going to look at those examples. Those examples are with the homework assignment, and then there's this other folder that has some more examples that was separate. Okay, all right. Now, let me back up a little bit and run the homework assignment, the demo. Oh, actually, let me show you something else that's on the website, course website. You know how I can just right-click here and say Open Command Window here? And I pointed out to you that on your computer at home, probably what you have to do is hold down the Shift key, then right-click, and you'll probably get Open PowerShell Window here, which is not as good, okay? If you want what I have on this machine, if you want to be able to just right-click and get Open Command Window here, I put a link to a thing you can download that'll do that for you. So this is an article that some programmer wrote explaining how to get back Open Command Window here. It used to be in Windows 7. What he means by get back is you're getting something that was in Windows 7 that they removed from Windows 10. So he wrote a little script to put it back into Windows 10. And you can download the script from the end of his article. Where is it? You can download the script from the end of his article, but I put a link to it right here. So if you download that zip file and you unzip it, you double click on this, what's called a registry file. You double click on that registry file, and that's a little script file that modifies what's called the Windows registry that puts this Open Command Window here prompt back into Windows. Okay, so if you want to do that, if you want to try that, it was one of the, when I first installed Windows 10, this was one of the very first things I went looking for. I started Googling around. As soon as I saw that it was missing, that the Open Command Window here was missing, I immediately started Googling to find it, to find out how I could put it back. And there's most programmers end up doing this, because unless you're someone who, well, first of all, it's a pain to have to hold down the Shift key when you right click. And there's still more people using the command window than there are using PowerShell. Right now, people use both. I'd say there's probably still more people using the command line than using PowerShell, but they're both used a lot. But Windows removed this Open Command Window here, so you have to put it back. And the easiest way to put it back is just to download this zip file and double click this guy here. And then you'll get a pop-up window asking you if you agree to run this script, and you just say yes, and then you should have this Open Command Window here. Okay, and I think it's really useful. Oh, if you go here and you type CMD, that starts a CMD, but it starts it in your home directory. Okay, it starts it, see, under C users. I'm logged in as classroom, so it doesn't let you control where the command prompt is. So you, like, I can CD to the desktop now, so I can be in the desktop, but I have to move around. I have to type commands to move around. If I just want to open a command, if I just want to open a command prompt in this window, it's just nice to be able to say, give me a command prompt. See, I'm in that window there. So you can see that the path, see, the prompt shows you where you are and what folder you're in. So I'm in that folder there. Oh, I can't, let's see, let me show you, you can see both at once. Okay. So, okay, there. Now you can see it's the same folder. The folder that this command prompt in is this folder that the Explorer is showing. So now the command prompt is showing me the same thing Explorer is. Okay. And if, for example, if I type dir in here, I get the directory listing of that folder, which is the directory listing of this thing here. Okay. So pretty much anything you can do with the Explorer, you can do with CMD. And anything you can do, actually, the truth is you can do more with CMD than you can do with the Explorer. We saw that when we were running these programs. The CMD is actually more powerful than Explorer is. Okay, there's a limit to what you can do by right-clicking and shift-clicking and double-clicking. The actual full power of Windows and the full power of Linux really comes from the command line. Now, that full power is usually only needed by system administrators or computer programmers, so Microsoft doesn't make a big deal out of the command line. But like Linux machines make a big deal out of the command line because Linux machines are mostly used by system administrators and programmers. But you can do more with the command line than you can do with the GUI. Okay, so now, so if you want that command prompt here, you can. I put the link up there for you to get it. Okay, now over here, I'm going to open a command prompt. Remember, the idea of the homework assignment is there's this source file, okay, that generates lots of random numbers in kind of a messy way. And then there's the filter program, and you can take the output of source and put it into filter. You have to write filter. Whoops. And filter, filter reads what, well, if you just run filter reads from what we call standard input. Right now, standard input is the keyboard. And it takes what's input and it makes it into columns. Okay. Then Control Z tells it there's no more input. Then if I type source and take its output and put it into, now what this is doing is it's replacing the keyboard input to filter with the output of source. See, what was keyboard input here becomes output from source here. This is what we call standard input. Filter read from standard input. When I run it this way, standard input is the keyboard. When I run it this way, standard input is the output of source. There's no change happening here in filter. Filter, this is the same filter here as it is here. The beauty of this is that filter reads from what it thinks is standard input, and we control what standard input really is. So here, standard input was a keyboard. Here, standard input is the output of source. Let me do you another example. I have a data file here. See, it's a bunch of numbers in it. I'm going to run filter now, reading that data file. So I type filter, and here's the command to say, now standard input for filter should be the data file. This little less than symbol, think of it as an arrow. It's saying that data should go into filter. It's called I/O. We have a name for this. This is called I/O redirection. The thing I typed before is called a pipe. This is called I/O redirection. In this case, it's input redirection. I'm telling Windows operating system, run filter, but make its standard input that file. Okay, so now it read from the file. This is a pipe. This says run filter with its standard input being the output of source. This is run filter with its standard input being a data file. Okay, and then I can also direct the out. Notice that the output's showing up on the screen. I can also do the following. I can send the output to a temp file. I didn't see anything happen, but if you notice over here, there's now a file called temp, and that file called temp holds the output. Okay, I ran filter, and I redirected its input to that file, and I redirected its output to that file. Without the output redirection, the output goes to the console window. What I'm redirecting is printf. The way a program gets output is by using printf, but printf doesn't print to the console window. Printf prints to whatever is standard output. So here printf is actually talking to that file, to EMP. Here, printf is talking to the console window. The operating system is controlling what printf talks to. So in this program, there's a printf, and the print prints to the print prints the standard output. Here, standard output is the console window. Here, standard output is a file, and it's Windows operating system that controls that. I tell the Windows operating system, run this program with standard output being the file, or I tell it, run this program with the standard output being the default standard output, which is the console window. And I'm telling it, run this program with the standard input being that file, or run it with the standard input being the default standard input, which is the keyboard. Okay. Okay. So the standard input was the keyboard. Okay. And I can do any kind of combination I want of these. So for example, here's a funny one. Run filter with keyboard standard input, but send the output to. Okay. Now when I type input and I hit enter, I don't see any output, because the output is accumulating right now in this file over here. The output's accumulating. Well, it hasn't actually shown up. Actually, it's going to accumulate there. You have to type a bunch of input before the output shows up in there. I probably can't type enough. Right now, Windows is buffering the input, so it's not going to show up there for a while. I think I have to type a lot of characters before the output. Right now, the output's being stored by the Windows operating system before it dumps it into that file. So it's not showing up in that file. Now, if I do, here, watch. If I tell it, I say, I'm done. See, now it showed up there. Okay, let's try that again. Okay, here's some input. Now, if I go over here, oh yeah, it has been updated. Okay, well, now, but the output, it's the file got emptied. Now there's new stuff being sent to it, but it's not showing up over here yet. Yeah, see, it's not showing up yet. So it's being buffered by the operating system. So right now, the output is being stored by Windows temporarily before it dumps it in that file. When I say there's no more input, then everything gets dumped to the file. Okay. Right. So this is the kind of stuff we want to get used to, using the command line, IO redirection and pipes. Okay. Now, the filter program, it's getting input from 4 different places. We've seen 2 of them so far. Okay. The filter program gets input from the command line. Those numbers affect the filter program. Like this thing says use 2 columns and do 1 decimal place. Okay, so now I give it some input. It read that number, so that number became input to this program, and that number became input to this program, and then what I typed here was input to the program. Those inputs came from different places. That's called command line arguments, and that's called standard input. Now, there's 2 more places where this program gets input from. I can create, in the homework assignment, it tells you that you can create an environment variable CS302 columns. Okay. So here's what that means. In this command prompt, this is a programming language. In a programming language, you can create variables. So I say set 302 columns equal to 4. I just created a variable in this programming language. Now if I run filter and I give it some numbers, there's 4 columns. Now notice that the default number of columns was 3, but the program's now reading that variable. That variable is called an environment variable. There are variables in this programming language called CMD. Okay, and you can set these variables in CMD, and then your program can read them. They're sort of like super elaborate global variables. They're variables that the program can read from the command line. Okay, so this program gets its input from, now the way this program works is a command line argument here overrides that variable there, though. So if I say run filter with 1 column, that command line argument overrides that environment variable. See, there's only 1 column of output. Okay, but if I run the program with no parameter there, if I run the program with no command line argument, then the environment variable has its effect. Okay. Now I can erase the environment variable by going up here and going back to that command and saying equal nothing. That actually erases the variable. Most programming languages don't let you erase a variable. The variable goes away now. Okay, so the variable's not there. So now if I run filter, it's back to its default of 3. Okay. If you want to see all the variables, you just type set by itself. There's all my environment variables. Most of them are set by the Windows operating system automatically. So for example, the there's an environment variable called app data, which is a folder on your computer. There's what's your home drive? It's usually the C drive. What's your home path? I'm logged in as an account called Classroom. What's my Java home? Which version of Java is my default version of Java on this computer? And my default version of Java on this computer is JDK 11. Okay, so you can see that there's all these environment variables that these are put there by the Windows operating system. And if I set one myself, so let me go back and set the one I put. Okay, so now I'm going to set this environment variable to 5. And if I type set and I look for it, they're in alphabetical order. There it is, CS302 columns equal 5. See, I created that variable. Okay, so you can see all the environment variables. Okay, if I close this command window, that environment variable goes away with it. Okay, now let me reopen this command prompt. Now I look at the environment variables. These environment variables are there permanently. These are there when I boot my computer. These environment variables are set. The one that I set in the last command prompt is gone. It only lives in that command prompt. If you want to create a permanent environment variable, it's a big pain in the butt to do it in Windows. You do right-click, properties. Don't do this. Nobody in the world recommends you ever do this. But you go to My Computer, you right-click it, and click on Properties. You go to Advanced System Settings. You know, so you have to type in a password to do this. I'm not even, well, I'll go ahead. Let's see if I remember the password. Where is it? Oh, here it is, environment variables. You can set environment variables. Don't ever do this. It's not a wise thing to do. Okay, I'm going to click cancel here. So you can actually set these the global environment variables. Now, some of them you can set by, here's a cute one. You're going to use this in homework. Pardon me?
Your screen has gone black.
It's still
Since
black?
you had to put in your password,
Yeah.
it's been black.
Shoot, stupid bright space. Oh, no, Zoom, stupid Zoom. Damn. I'm going to stop sharing and restart sharing. Maybe, pardon me? Did it come back?
No, you can just unshare and reshare.
Yeah, that's what I'll think. I'll stop sharing and Start sharing again. Zoom's got too many weird features. Okay, did the desktop come back?
Yeah,
Yeah.
you're back.
Yes, it's
Okay,
back.
good. Okay, yeah, that's the Zoom is weird. Okay, yeah, it has it's trying to be secure, so it's deathly afraid that it'll somehow show you a password, so it blanks. Yeah, so I didn't realize it was going to completely blank the whole screen and leave it blank when when a password prompt came up. Okay, all right. So don't. Okay, now let me show you. Okay, let me show you something that's you'll need this in a later homework assignment. Okay, these are the environment variables that are given to you by Windows automatically. See, one of them is called prompt. That's the prompt here. If I can type the prompt command and I can change the prompt. I'm going to change the prompt to just the greater than symbol. Right now the prompt is the path and the greater than symbol. I misspelled prompt. See how my prompt changed? It's now, I lost the path. Now look at the environment variable. I changed the environment variable. The prompt command changes that environment variable. So the environment variable, the environment variable is given to you by Windows, but you can change it if you want. Now, if I change it here, it's only changed in this one window. So for example, if I close this window and I reopen another command window, my prompt's back to the way it was. Okay. So changes made to environment variables in this window live only in that window. Okay. So I can, like, here's a prompt. There's my, here, my prompt is some people like this. The prompt is the time of day. If you want to sit there and know what time it is all the time, you can make your prompt the time of day. This can be actually real useful in a script file where you can record what time you typed commands in. This can be useful for, if you're typing commands and you're doing something, when you save this window, remember I showed you could select all and you can copy what's in here. You can make a record of when you typed commands. You can have this thing showing you exactly what time it was, everything was. So you get to control the prompt. Like here, I can do the prompt. I can do the path and the time of day. See, get a pretty unreadable prompt, but it's showing me my path and my time of day. Okay, right. So the prompt turns out to be an environment variable. Okay, so the filter program reads an environment variable. It reads one for columns and one for precision. Just like it has two command line arguments, it's got two environment variables, okay, which can be there or not. And if there's a command line argument, it overrides the environment variable. So the command line argument has precedence over the environment, over the command line arguments have precedence over the environment variables. Now there's another place where this program gets its input. Okay, we're going through the places where filter gets its input from. It gets its input, now we've seen, from command line arguments, environment variables, and standard input. Okay, that's three of them. Okay, now there's a fourth place where it gets input. If I create a file called filter.config, so I'm going to create a file called filter.cfg. That's a typical Windows, Linux idea of CFG stands for a configuration file, a config file. And then if I put two numbers in there, those become the parameters for my program. Okay, so now I'm going to run filter. Notice I didn't give it any environment variables. I didn't give it any command line arguments. What did I put? And it's got two columns with 6 decimal places. So the first number in the config file is the number of decimal places, And the second number in the config file is the number of columns. So now, command line arguments override the config file. Five columns, but 6 decimal places. So the program read the config file first, then it read the command line argument second, and the command line argument overwrote what was in the config file. I mean, that's explained in this over here in this document, but that's the idea. The filter program, it reads a config file, environment variables, command line arguments, and standard input. Those 4 things in pretty much that order. Okay, so let me just, yeah. So the program, it reads the config file, reads that first, then it reads the environment variables, then it reads the command line arguments, and then after those give its configuration, then it starts reading the actual data from standard in. So the program will open the config file if it exists and read what's in there. Then it'll look to see if there's environment variables and read them if they exist. Then it'll check to see if there's a command line argument and use those. In each case, it's looking for what's the number of columns and what's the number of precision. Then after it's been configured this way, then it starts reading from standard input and prints the numbers to standard output with the right number of columns and the right number of decimal places. This pattern is ubiquitous in computer science. This is the way systems software, like suppose you have to set up a database system, or suppose you're setting up a web server, or suppose you're setting up some sort of big data system. You'll find when you read the documentation that all of them have a configuration file, which you can set parameters in, but you can also set environment variables, which override what's in the configuration file. And when you run the program, you can give it command line arguments, which override what's in the environment variables in the config file. And then the program will start reading its data. This is a ubiquitous pattern in systems programming, that software has a configuration file, environment variable. And it's not just systems programming. For example, Visual Studio works this way. There are config files, environment variables, and command line arguments to Visual Studio or Visual Studio Code. Your Chrome browser even works this way. So for example, if you Google Chrome command line options, you'll find out what are the command line options that Chrome takes. There's a whole bunch of them. If you start Chrome up at a command line, oh, you have to know the path to Chrome. But if you start Chrome up at a command prompt, you can give it command line arguments. Chrome also has environment variables that it pays attention to. Let's see. I think it has environment variables. Kind of. Yeah, these may not be environment variables. These may be internal variables. I can't remember. I think Chrome does have some environment variables. I think it has a few. Okay. This might be the thing to describe some of their command. But it's very common for software systems to use this pattern of some of the parameters of the software is in a configuration file, some of the parameters are environment variables, some of the parameters are on a command line, and then the program reads data. Okay. The documentation for the software has to tell you what should be in the configuration file, what environment variables the program looks for, and what command line argument the program expects. Okay, that's part of the documentation of a system. Okay, what we want to do next is, how does C code read a config file? How does C code read an environment variable? How does C code read a command line argument? Okay, that's the next thing. So let's start actually looking at code that does this. Okay, so me close these folders. If you go to the homework assignment folder, there's a folder called command line arguments. In it is it as both, I gave you a Java example and a C example of command line arguments. So let's look at the C example. And I actually might as well, and I'll open the Java one too. Oh, I don't have any Java tools in this editor. I thought I used to have Java tools, and notice that, see, when I open the C file, I get C tools. If I open the Java file, I don't have any Java tool. I could put one in there real quick, but I don't have any Java tools in this thing. I'm not going to do it. But so I'll compile the Java. We'll just look at the Java code. We'll compile it in a minute. Okay. So these are the command line arguments. See how main has arguments? See, argc is a count of how many command line arguments there are. And what the command line arguments, this is a pointer to an array of strings. Okay, now this is, we're starting to talk about C now. This is a pointer to char is what C calls a string. So this is an array of strings. Okay, so the command line arguments are essentially given to your program as an array of strings. Now let's compile this. Okay, let me open a command prompt in this window so I can run the program. Okay, so I'm going to run command line args.exe. Okay, now if I just hit enter, there was no command line arguments. Okay, if I type hello, there's one command line argument. Okay, if I type hello, oops. Yeah. Okay, there's 3 command. Now, actually in C, the name of the program is actually the first command line argument. So this thing actually has 1, 2, 3, 4, 5 command line arguments. See, there were 5 strings on the command line. The command line strings are the name of the program itself, hello, apple, pear. Now, what my program did was it just walked through that array. This is an array of strings. This is how many entries there are in that array. So I just wrote a loop that says for I equals 0, I less than argc, I plus plus, print the ith argument. So that's all there is to it. Okay. Now, there's some interesting things you could do with this. Here's 3 command line arguments, right? But I can group them together. If I put quotes around that and there, whoops. The quotes lump 2 things together into one complete string. So that's now 2 command line arguments. The command line arguments are command line args and A, B, and C. So there were only 3 command line arguments. Okay, so when the programming language that we're using allows you to group what you would think of as separate command line arguments together. Okay, so here's one command line argument. Okay. Okay. What if I want my command line argument to be quote cat unquote?
You could
try to the quotes. Pardon me?
Could you use single quotes?
Oh, that's a good question. Can I use single quotes? Yeah. Okay. The single quotes ended up being part of the command line argument. What if I wanted the double quotes to be part of the command line argument?
You just put 2 sets of quotes.
Okay, mate, let's see if that works. Try 2 sets of quotes. One set, okay. No, that didn't work.
You have to do like an exit symbol like you do in Java, which is I think the forward slash, the one that's under the pipe.
Yeah, that's the way you would do this in Java. In a Java string, if you want to quote in your string, you have to, what we do, escape the quote. So you have to escape the quote, and it worked. See, just like in Java. That's where Java got that escape. Java didn't invent that escape. They copied it from CMD, because this escape has been in CMD long before Java existed. So a lot of things that you know in the Java language actually came from the Unix command prompt. These ideas came out of Unix. Windows copied them into its command prompt, and the Java language copied them into the Java language because they were so common. So if I escape the quote, it becomes part of my string. Okay. Now put a quote here. Slash quote dog slash quote quote. How many command line arguments are there?
Just one.
Just one, and it is, the command line argument is quote cat unquote space quote dog unquote space. Okay, it's one command line argument. You can get it's just like any other programming language. It's real easy to write real unreadable code. Okay, but okay, so you have these little things you can do with command line arguments if you want to play around with them. It's not very common to want to do this kind of stuff. You rarely want to lump command line arguments together. You don't do this kind of thing very often, but you can. Okay, all right. So command line arguments are pretty straightforward. Your C program has them automatically. They are arguments to the main function. The command line arguments are actually arguments to the main function. The Windows operating system bundles them up. The operating system is bundling these up and turning them into arguments. Now, real important, 23 is not an int. 23 is a what?
String.
String. Yeah, if you want the number 23, you have to convert it, just like in Java. You have to convert it to an int because it's a string. This is an array of strings. So even if somebody types a number on the command line, the number is going to be given to the program as the string the string 501 or the string 23. Okay, so the command line arguments are always strings. Okay, so it's real simple to get command line arguments in a C program. Okay, the main method knows how many there are, and you have this array of them. The array is called argv. To give you an example how weird things are, the v, see, this is an array. It's the array of arguments. The v is actually the word vector. In the old days, arrays were called vectors. And in the C standard library, they're also sometimes referred to as vectors. So that's just a weird little carryover from the old days when people referred to arrays as vectors. So this is the argument vector, which is an array. Okay, so argv. Everybody calls it argv, the argument vector, and it's really an array, but vector is an old-fashioned word for array. And over here, this is the argument count. It counts how many entries are in that array. Why do you need this guy?
That way you don't loop out of bounds.
Well, why do you need a number to tell you how many things are in the array?
C doesn't keep track of that, right?
Right. The Java language, arrays know how long they are. You just ask the array, what's your length? And it'll tell you. C arrays do not know how long they are. So to protect you from, like you say, from going over the end of the array, you have to be told, here's an array and here's how many things are in it. So you have to be told, here's an array and here's how many things are in it. If this was Java, and we'll look at the Java code in a second, the Java code has the array, but it doesn't have the argc. Okay, so here's the Java code. See, main has what? An array of string. And there's no argc because the array knows how long it is. You can ask for the length of the array. This is what you get with a modern programming language. You get much nicer code. That's the difference between an older programming language and a more modern programming language. The more modern programming languages, arrays are smart enough to know how long they are. Okay, so array of strings, but you have to be told how long that array is. Okay, this is the equivalent Java program. It just loops through the array and prints out the entries in the array. So it does the exact same thing. So this is the Java version of the C program. The only big difference is the C program needs the length of the array, the Java program doesn't. And Java programs are just a little bit easier to read and to write than C programs are. Okay? So that's how a program can get command line arguments. Okay? Here's some examples here. Let me show you another example that's kind of cute. Okay. There's a funny command line argument, C star dot star. So it looks like there's only one command line argument. Oh, what did I do wrong? Oh, I deleted the S at the end. I accidentally deleted the S at the end. How did I get 1, 2, 3, 4, 5, 6 command line arguments? I only typed one. Does anybody see the trick?
It's a wildcard character, so anything that remotely matches is returned.
Yeah, I'm using what's called, the fancy word for this is called globbing. They actually, it's sometimes referred to as wildcards. It's sometimes referred to as glob patterns. In computer programming, glob patterns specify sets of file names with wildcards. Okay, some people like to call them wildcard patterns, and some people like to call them glob patterns because they glob a bunch of names together. What I said was the command line argument is anything that begins with a C, has anything after the letter C, then any extension dot. Yeah. So I said, now actually I don't even need that part. I think I could just do that. Yeah, I only need anything that begins with a C. Okay, so that was anything that pattern matched any file in this folder that began with a C. Okay, and notice that was a lowercase c. Case matters here. So if I change that to uppercase C, I get, oh no, I'm sorry. It did lower and upper cases. No, oh yeah, on Linux case matters, on Windows case doesn't matter. Notice that on Linux, in Linux, this one would not have picked up the capital C here, and this one would not pick up the lowercase c's here. Okay, in Windows, case doesn't matter. So lowercase c and uppercase C don't matter. Okay. And okay, so notice that it's kind of tricky. There's only one command line argument, but that command line argument is a special case. It's called a glob pattern. And the Windows operating system, not my program. Notice it's not my program that did that. What is that the Windows operating system expanded that C star to all those command line arguments. So that was done by Windows before my program even ran. So Windows expanded this single command line argument into 1, 2, 3, 4, 5 command line arguments, then ran my program. Okay, so there's little quirks like that. So in the source code here, I put some examples here to point out to you some of the things that are going on there. Like this was the using quotes to lump command line arguments together. This would give you all the files in the folder because star matches everything. And this gave the C files in the folder. And when we did here, gave all the files that begin with the letter C. Okay, so those are called glob patterns or wildcard patterns. Okay, and Java does the same. I mean, actually, if you ran this with the Java program, it'd be the same because the wildcard's done before the program runs. So it doesn't matter if I'm running a Java program or a C program, the wildcard expansion is done by Windows before it runs the program. Okay, all right, so there's command line arguments. That's how a program, that's the simple way a program can get at its command line arguments. Now let's look at environment variables. So the next folder here shows you some sample code of environment variables, and it shows it in C and in Java both. And there's also like these shortcuts are to web pages where you can read about command line argument. Like this case, arguments to main. Okay, so there's a nice explanation of arguments to main. Nice one-page explanation. Okay, and there's a here's a page that describes the Java. See, it's the Java tutorial, and this explains command line arguments in Java. There's not a lot to it. See, it's just a simple one page. Okay, but there's the documentation where Java explains command line arguments. Okay, there's a couple other ones. I forgot this. If this, oh, somebody disappeared things. Ah, that's the internet for you. Stuff, it's there today, gone tomorrow. Okay, so that one disappeared. I have to remember to either delete that or replace. Well, remember that trick I showed you a little while ago? Something's not there. One common trick is to see if it changed names. Is it still really there? Is it really gone? Ah, see, they're not letting me see their folders. I do this all the time. Eventually, well, that's not very useful. I'm just at their home page now. A lot of times when something disappears, if you look for it, it's still there. It maybe just changed names or it changed from one folder to another. So if you were looking for something and it disappears, it's worth playing around with the URL to see if you can find the thing you were looking for. Okay, right, in this case, it didn't work. Okay, and here's another one. This is a well-known online C tech. Oh, that one changed too. But that one I know is still there. You probably just changed names. I probably just have to go look. I bet he changed the URLs. He probably reorganized his website and changed the URLs. So there it is. Okay. So there's the command line argument. Okay. So I can update that URL. I can update this one. Okay. See, this is the internet's like that. People reorganize their websites all the time. You create a shortcut to something on the internet, and then it just moves on you. Okay. But if you play around, a lot of times you can find the thing you were looking for anyway. So I'll try to remember to update those. I should try to remember to update those later on. Okay. Now, let's look at environment variables. Okay. So here's some websites. Like here's a Wikipedia page about environment variables. Environment variables exist in Linux, Mac, Windows. They're ubiquitous. It's every operating system. They were invented by. No, I don't even know if they were invented by Unix. They might even predate Unix. I bet they even predate Unix. They may have the history here, but I bet they even existed before Unix existed. Okay, now here's the C program that tries to read an environment variable. There's a function in the C language called, where is it?
Right above your
yeah, there. This function here, getEnv, is the C function for reading an environment variable. Now, what I'm going to do is I'm going to let somebody type on the command line the name of the argument. So this program is actually using both argument variables and command line arguments. So what I'm going to do is okay, let me compile it. Okay, and then I'll go here and run it. And the way you run this program is like one of the command line arguments that was built into Windows was prompt. So my program read that command line argument and used it as a parameter to the getEnv function, and getEnv read from the environment of this shell, the prompt, and it read the environment variable is $P, $G. Okay, and I can verify that by typing set, and I see, yeah, my prompt is $P, $G. Let me change my prompt. I'm going to set my prompt to $T, $G. I misspelled prompt again. Okay, now my prompt is, okay, now I run my program that reads environment variables. See, and it notices that it read that environment variable. Okay, so this program steps through the, okay, now let me read another, let me run the program again. So I'll read prompt and program files. See, that's one of the environment variables, program files. Okay. So the value of prompt is $T, $G. The value of program files is C:/program files x86. Okay, so it read those environment variables. So this program steps through the command line arguments and uses each command line argument as a parameter to getEnv and getEnv. Now, now what happens if I tell it to look for the environment variable called Bob? Now, how did the program know there's no Bob environment variable? If getEnv returns a null value, then there wasn't a value. Okay, so if env returns a null, actually, well, let's check. Now we see. Notice how if not value, there is not an environment. There is not an environment variable. Otherwise, there is an environment variable. What does getEnv do? So let's use my little Google tool. Okay, here's the getEnv function on the internet. Okay, this is actually the Linux man page, but getEnv works in Windows exactly the way it works in Linux. It's really part of the C anyway. Okay, okay, getEnv gets an environment variable. Okay, getEnv returns a pointer to a string. Okay, and if it fails, let's see. See, here's the return value. The getEnv function returns a pointer to the value in the environment, or null if there is no match. So it returns null. Now, null is really 0, and 0 is false. See, this is the stuff about C. Null is really 0. C doesn't have a Boolean value. So 0 plays the role of false. So this is saying if it's not false, if it's not 0, there is a value. And if this thing is 0, then there was no value. There was no environment variable matching that string. Okay, all right. So when I ask for get the environment variable called Bob, I get told there is no environment variable named Bob. And if I do Bob and Jane, I get told there is no Bob and there is no Jane. If I do Bob, Jane, and prompt, there's no Bob, there's no Jane, but the value of prompt is $T, $G. So the program is stepping through the argument list and using the argument list as the names of environment variables and passing them to getEnv. GetEnv takes in a string and returns a string. Okay, you can see here value is a string. You have to remember that pointer to char means string in C. Pointer to char is what C thinks of as a string. Okay, so this function takes in, now argv is an array of strings, so that's okay. Argv is an array of strings. GetEnv takes as an input as a string, and it returns a pointer to a string, and but it returns null if it couldn't find things. Okay, it returns null when it can't find a string. This is the way we document. This is like the Java doc, but for C. It tells you the name of the function. It gives you this thing called the synopsis, which is really what the synopsis is what include file do you need to use to call that function, and what is the declaration of that function look like. Okay, so that function is in this include file. So for example, see, it's in standardlib.h. If I go over here and I comment out that line, and then I try to compile this, I get an error message saying, I don't know what get env means. Because this is similar to, but not the exact same thing as an import in Java. Okay, get env needs to be included from standard IO. That's just like in Java, you need to import from things. Now, imports and includes are technically very different things. They're not at all the same thing, but you use them the similar way. You have to include things to be able to use them. So you have to know what library a function is in. So the synopsis tells you which include file to use. Now, there's a little bit of a trick to this. This is the Linux man page. Every once in a while, Windows will put a C function in a different include file than Linux does. I've never understood the rhyme or reason for that, but every once in a while, the Windows system will have a function in a different include file than Linux does. Okay, I have no idea why they do that. So sometimes you want to go, you can go look up the Windows version of this. Let's see if we can do the. Windows has its own documentation. Microsoft Docs, get env, okay. Ah, see, here's where they tell you which header file. See, the Linux people did that right at the top of the page. That's the first thing they tell you, which include file. Microsoft, you have to go down the page before you find out what is the required include file for that function. Okay, all right. So this is Microsoft's way of documenting. I tend to prefer the Linux way, but sometimes you have to look at both, because every once in a while, Windows will do things a little bit different than Linux does it. Every once in a while, Windows does things a little bit differently. Okay, but if you Google get env, you'll almost always get the Linux docs, because it's Linux is even though Windows is by far the more dominant operating system, more programming is done for Windows or Linux. More people have installed Windows, but more people program Linux. There's a lot more programmers using Linux than there are. I mean, most people install Windows and just watch movies on it. You know, they're not programming, they're just watching movies or reading their email or browsing the internet. You know, the actual real programming tends to be done much more on Linux. Okay, so if you just Google something like get env, see the very first link, Linux man page. Okay, and then you gotta be careful. Like here's the get env that's in the PHP language. That's not the one you want. You know, reading that page isn't going to help you much. That's the PHP language's version of get env. Okay, here's another C version. This is a good website. This is a kind of a neutral website. It's not Linux based, it's not Windows based. It's just the C language, and it tries to be platform neutral. A lot of times that's a good place to go and to get documentation. It's called Seedplusplus.com. Okay, and it's really good. It's a really good website for looking up C stuff. Okay, all right. Now you can also look at the Java version of this. If you're curious how Java would do it, there's system.getEnv, okay? And you don't need to import system. The system class is automatically in every C program. So it's just system.getEnv. And I do the same. It takes as input a string, and it looks up that string in the environment variables, and it returns a string, okay? So same kind of thing. So the C, notice that the Java code and the C code look a lot alike. In your homework assignment, if you can write it in Java, you can probably translate it to C. If you feel a lot more comfortable with Java, write the homework assignment in Java, and then it's going to be about 1 page of code, and then work on translating it into C. You can see here that translating Java and C with simple stuff like this is not that bad. They're pretty Java was based on C, so there's a lot of commonality there. And if you wrote the homework assignment in Java, you'd be very far along the way towards translating into C. Okay, and it would also be real educational for you to see how you would write something like that, how you would do a little bit of systems programming in Java. So that's one reason why I give you examples here in both Java and C to help you see how to do these things in Java. You can add that to your Java repertoire, and then you might be even able to write this homework assignment in Java. Don't turn it in Java. You won't get much credit for it, but but writing it in Java and then translating it into C is not a bad strategy for starting out learning C. That's one reason I gave you pointers to those books, C for Java programmers. You know, those books that were on C for Java programmers in the syllabus, they help you do that. They help you translate between Java and C. Okay, all right. So now we've seen how a program can read environment variables, and we've seen how a program can read command line arguments. The next thing is, remember, the program needed to read environment variables, command line arguments, standard in, and the config file. So the next thing is, how does a program open a file and read it? Okay, how does a program open a specific file and read what's in that file? Okay, let's see which one were. Oh, no, I'm sorry. I don't think I actually had. No, these are scanf. Scanf reads from standard input. It doesn't read from a file. Actually, okay, there's not an example here of how to read a file. Let's switch to the other folder that has examples. All right, okay. It's in the other folder. This folder here says example one, homework one.example. Let's look to that folder. So let's switch to there. Okay. In this folder is an example called Incrementer. Okay. Incrementer is based a lot like, it's something that acts similar to filter. Okay. Let me compile it and run it and show you what it does. Okay, so there's this program now called incrementer.exe. If you run it, it's just waiting for you to give it numbers. If you give it a number, it increments it. See, I type 5, it gives me back 1005. I type 9, it gives me back 1009. So what it's doing is that each number you type in, it increments it and gives you the input incremented output. How much does it increment it by? Well, that's a parameter. So if I give this thing the command line argument 5, it's now taking each number and incrementing it by 5. Okay. Now it can also take an environment variable. Okay. The environment variable, if I go look in here, the environment variable is called incrementer value. So if I go here and I say set incrementer value equal to 40, now I run incrementer and it's incrementing by 40. Okay. Now I can override the environment variable with a command line option. So now that 10 overrides just like your filter program. This program reads from a config file, an environment variable, command line argument, and standard in. So this incrementer program is structured just like your filter program, but it just doesn't do very much. It just takes one command line argument, one environment variable, and it just adds that value to whatever number is given in. So you give it the number 2, and it increments it by the incrementing amount. Give it the number 6, and increments it by that. Okay, so now I can also create a config file in that folder. Now, actually, I already have a config file in that folder. The config file is where the 1000 came from. See? Now, if I delete the config file, Well, actually, I'll just change the name of it. Okay, so I'll change the name of the config file. Now, if I run this program, its default value is to increment by 40. See, now there's no command line argument. There's no config file. Oh, no, wait a minute. It's using the environment variable. So now I have to clear the environment variable. So let me clear the environment variable. Okay, now there's no environment variable, no command line argument, and no config file, and it increments by 0. Okay. Now let's look at the code for it. This is the structure your homework assignment will have. Okay. There's the default value that you increment by, 0. Here's how you open a config file. You create something called a file pointer. You call the file open function with the name of the file. I want to open it as read only. Okay. So I call the fopen function. It gives me back a value for the FP. FP stands for file pointer. It gives me back a value for the file pointer. If it's null, that means the file wasn't found. So if it opens the file and gives me a valid pointer that's not null, then I read the file. But if it can't open the file and it gives me back null, I just skip over this and ignore the file. So this is a tricky little line of code that calls the function, sets a value of a local variable, checks the return value of the function, and then branches on the return value of the function. C programmers love to write code like this. Everyone thinks this is really cool to write a single line of code that does 5 things. Yeah, I kind of it's fun to write this if you're used to it, but it can be hard to digest a line of code like this because it's doing so much. But eventually you get very used to it because you pretty much all you need to do is change. If in your code, just change the name of that config file and it'll work. Yeah. So you just change the name of that file and it pretty much will work for you. So you need a thing called the file pointer object. So this is a pointer to a file object. You call the fopen function with the name of the file you want to open. In our case, you can open it for reading, you can open it for writing, you can open it for read and write, but we only need to read. So you can open it for reading, open it for writing, or open it for read write. Okay. In our case, we just need to open it for read. You get the pointer to the file if it's opened successfully. And if it can't be opened, you get back null, but then the if statement just passes over that. Okay, so there's how you would open a file. Then here's how you would read from the file. You read file scanf from that file. See, now FP is that file there from our point of view. See, once you've opened the file and got back that file pointer, the file pointer is the file from the point of view of my C program. So now I scan, just like scanner in Java got its name from the scanf function in C. Okay, scanf reads from a file just like scanner does. But I'm scanning from my file pointer. And then I use a printf like parameter string. What this is saying is scan integer into that variable there. Now, this is another one line of code that's very tricky to read. Scan from this file one integer and put the value in that variable. Okay. Now, scanf actually has a return value, and I'm ignoring it. And I probably shouldn't, but I'm ignoring the return value of scanf. One last thing, if I Google I'm going to use my little Google tool. Okay. I didn't get a scanf. Okay. Scanf returns an integer. What that integer is a count of how many things scanf read. In my code here, I'm asking scanf to read one integer. So the answer could be 1 or 0. It could be 0 if it didn't find an integer. If it didn't find an integer, then I would get exact 0 here. I actually don't care. If it doesn't find an integer, it didn't do anything to this variable here. So if it opens the file and it finds junk in the file and it can't find an integer in the file, scanf will return 0 to mean I didn't read anything. And if it opens the file and does find a file, it'll return 1. In my case, I don't care. I just got the value I wanted in here. If there was a value in the config file, it's now in my variable. So I kind of ignore, but I could do int r for return value, but I don't have any real use for it. Okay, the scanf function returns an integer value telling you how many things it read. And in this case, I don't need that return value. Okay, but in more complicated cases, I do need to use that return value. Okay, and then so there's how you read a config file. Then what we've seen already, there's environment variable, there's command line arguments, then it starts reading from standard input. Does somebody have a question?
Yeah. In that, getting the config file.
Say again?
For the config file,
Mm-hmm.
could you use like a wildcard instead of having to specify the name of the config file?
No, don't do that. That's a very bad thing because you could be reading bizarre files. No, config file, you want to read a specific file. That would be a very, first of all, wildcards don't work in the fopen can, actually, the answer is no, you can't do that. Fopen does not accept wildcards. Only the command line argument, the command line accepts wildcards. Fopen doesn't. There's a separate function in the C library for expanding wildcards. Okay, so if you actually want to use a wildcard in your C program, you actually have to call a special function to expand the wildcard. The fopen function doesn't understand wildcards, so you can't do that. It'll just say file not found. It will look for a file named star.cfg and it won't find it. So it will not use command. It does not use globbing. Fopen can't use globbing. Okay, well, we've run out of time. Anybody else got a last minute question? Okay. Yeah, your homework assignment is structured exactly like this guy. But your homework assignment needs 2 arguments. It's going to open the config file and read 2 things from it. It's going to read 2 environment variables. It's going to read 2 command line arguments. And then it's going to start processing the data and using it, okay? So this example structured very, very much like your homework assignment, okay? So it's a good little a demo for you. And then there's a Java version too. So if you feel more comfortable with Java and you want to practice translating from Java to C, here's the equivalent Java version using a scanner. Okay, so the notice that line of code there kind of looks a lot like this. Well, it's a little bit of a mixture of this line of code and this line of code. Okay, so there's commonalities and differences. Okay, so there's the Java version of it, and there's the C version. And study this one carefully. Actually, your homework assignment, you could just copy and paste this code and start expanding on it. That'd be another strategy for doing the homework assignment. Is that one strategy for doing the homework assignment is to try to expand this code. The other strategy is the one I gave you in the website. Or is it? Do this first, which is only a few lines of code, then do that, then do 3rd step, then do 4th step. Either strategy is going to work. You might try both strategies, but get this first step working. That's one way to do it. Get the first step working, get the second step working, get the 3rd step. In fact, you could do both strategies. You could start with this and get this thing to do the first step for you. Then modify that to do the 2nd step. Okay. All right. Well, okay. We've run out of time. I'm going to go ahead and quit now. And we don't meet on Monday, right? Monday is Martin Luther King Day. So the next class will be a week from today. Okay. So the next class will be a week from today. And if you have questions about the homework assignment, send me email. Don't wait till the last minute. This is not easy stuff. Believe me, this is not, you're not going to write this in an evening. I guarantee, unless you've written C code before, You will not write this in one evening. So don't wait till the last minute to try to do this. If you start on it and you do an hour a day, you can probably get it done without much trouble. But you'll need time to solve little problems. C is a weird little language to use. You'll get little weird problems and you'll need to solve them. Okay, so don't wait till the last minute. Okay, so I'm going to go ahead and stop sharing now, and we'll meet again in 1 week. Have a nice weekend. Bye.
Have a good weekend, Professor.
Thanks. Bye-bye.